Hello everyone, welcome to our report, Image Retrieval Algorithm based on Fractal Coding. This report consists of the following 6 parts. The first is the research background. Content-based image retrieval technology is widely used, and its core technology is feature extraction algorithm. According to the different features of the extracted images, content-based image retrieval techniques can be divided into the following 4 types. 1. Color-based image retrieval technology. The most typical is image retrieval technology based on color histograms. The color histogram of the image is statistically obtained, and the median distance between the color histograms is calculated as a similarity measurement. 2. Shape-based image retrieval technology. It mainly uses appropriate image segmentation algorithms to extract features of the target boundary or region of interests. This technology is more advanced than acquiring the color histogram of the image. 3. Texture-based image retrieval technology. For example, the gray histogram method is used to obtain the texture feature, and then the median distance of the texture feature is used to measure the similarity. 4. Image retrieval algorithm-based technology on factual coding. This technology uses a factual coding algorithm to extract the factual features of the image, that is, the image factual coding file. The factual coding file can uniquely characterize the original image, which greatly improves the recall and accuracy of the image retrieval technology. However, because the factual image coding process is more complicated, the coding time is too long, so many methods have been proposed to increase the encoding speed. For example, Fractal combines wavelet transform, nearest neighbor matching algorithm, and Elector to improve coding speed. An image retrieval algorithm based on college arrow histogram is used to improve recall ratio and precision ratio. The paper proposes a rapid image retrieval algorithm based on image entropies and Fractal blocks. At first, the image 2D entropy is used to screen an image library so as to decrease the retrieval scope. Then, the to-be retrieved image is rapidly matched with Fractal block parameters of the images in the library. The method does not request pre-encoding of the image and directly takes the image Fractal block, namely R block, as the basis to judge the similarity between images. Therefore, an online real-time retrieval function based on Fractal encoding is realized. Basis Fractal coding algorithm. It uses the principle of self-similarity in Fractal geometry to compress image. The encoded file formed after compression is the Ifs code, and the data storage capacity of the Ifs code is much similar than the original image. If the Ifs code of the Fractal tree is known, the original image can be generated by an inter-retrieve method. The acquisition of Ifs code, the college theorem, is used to generate the self-similarity between image blocks. The steps of the Fractal coding process are composed of the following 4 steps. Among them, the calculation of the Ifs code for each image block is relatively large, and it consumes a lot of time. Therefore, it is difficult to achieve real-time retrieval by using Fractal codes for image retrieval. In order not to affect the retrieval speed, the corresponding Ifs code must be obtained for the retrieved image and the image in the gallery. and then the Ifs code is used for comparison and retrieval. In order to achieve online real-time retrieval, this paper proposes a fast image retrieval algorithm based on image entropy and factoral blocks. First, use the image two-dimensional entropy to flatten the image library and narrow the search scope. Then, the factoral block parameters of the image to be retrieved and the image in the library are quickly matched. This method does not require pre-coding of the image and directly uses the factoral block of the image, that is, the R block, as a basis for judging the similarity of the image. Therefore, the online real-time retrieval function based on factoral coding is realized. Factoral coding is a lossy compression algorithm. The main reason is that the D block adjusts the image brightness through a fine transformation during the factoral coding process. Change the frequency domain information of the original image is distorted to the original image and overlaps the divided the same image. The D block is composed of R blocks that do not overlap each other, and the D block can be said to be composed of R block that are collaged into this block. Then the image R block can be used as a basis for judging the similarity between the images. In this paper, the image R block is used as a basis for judging the similarity between the images, and the Ifs code calculation of the image is replaced by the calculation of the structural similarity between the image blocks to shorten the retrieval time. The structural similarity calculation is shown in the figure, and the value range of SSIM is for minus 1 to 1. The larger the SSIM value, the more similar the image X and Y. In order to further improve the time-consuming retrieval of the retrieval system, this paper introduces image entropy to screen libraries simply and quickly, as far as possible to ensure that the rescreened database image is similar to the image to be retrieved to be a center extent. The one-dimensional entropy of an image reflects the distribution of expo values in the entire image, so it can be used for image screening. The image entropy of 4 images is calculated, and it is found that the more similar the images are, and the corresponding image entropy is also similar. Therefore, the image entropy can be considered as a basis for screening the image database. Although the one-dimensional entropy of an image reflects the distribution of expo values in the entire image, for images with completely different grayscale histograms, if they have the same probability distribution, they have the same information entropy but cannot reflect the image expo values are distributed in space in the entire image. Therefore, position distribution information is introduced, and the gray average value of the pi expo neighborhood is added on the basis of the one-dimensional entropy, and the two constitute the two-dimensional entropy of the image. Using MATLAB to also calculate the two-dimensional entropy of the 4 images in the figure, it is found that the two-dimensional entropy difference between dissimilar images is more obvious, and it can be more accurately and quickly classified the screened-out similar images than the one-dimensional entropy of the image, which is the speed of image retrieval. The improvement provided beneficial help. The algorithm flow of this article is shown in the figure. Calculate the ranking of the key image and the fitted image library image by the difference of the two-dimensional entropy and the structural similarity ranking, and select the top 10 as the retrieval result. This paper conducts experiment on the image retrieval algorithm based on color histogram, and the image retrieval algorithm based on two-dimensional entropy and factual technology, and retrieves the top 20 images with similar output, and compare the experimental results according to the precision and recall performance indicators. Perform comparative analysis. Next, we will test 300 standard ORL face library. There are 30 people in the library and different facial expressions, each with 10 images, totaling 300 face images. For the fairness of the experiment, the same retrieval is used for the two algorithms. The image is tested. The inspection image is shown in figure 4-3, and the test results are shown in figures 4-4 and 4-5. It is obvious from the figure that the algorithm in this paper can retrieve similar images faster and more accurately than the color histogram method. The precision ratio and the recall ratio curves of the two image retrieval algorithms in the ORL face library are shown in the figure. It can be seen from the figure that under the same recall rate, the precision of the algorithm in this paper is obviously high based on the color histogram retrieval algorithm. Finally, the comprehensive library is tested. This experiment uses 5 types of libraries, including landscape architecture drawings, potted plant drawings, human active drawings, fruit drawings, and animal drawings. There are 100 images for each category. A total of 500 images and color histograms are used respectively. The retrieval method and the retrieval method of two-dimensional entropy and factual method technology are tested. It can be seen from the test images that the algorithm in this paper can retrieve more similar images. According to the test results, the image retrieval algorithm based on two-dimensional entropy and factual block proposed in this paper has higher precision ratio and recall ratio than the color histogram retrieval algorithm in the comprehensive library retrieval test, and the retrieval time of the algorithm in this paper is longer. Thus, further proves the advantages of the retrieval algorithm proposed in this chapter. Factual codes pay more attention to the spatial structure of the image and are not sensitive to the frequency of the gray value of the image. Therefore, the application of factual technology in image retrieval has been further developed through research in recent years. But the extraction speed of factual codes still needs to be continuously improved. The future research on factual technology is mainly in following aspects, such as the speed up of factual coding and the application of factual coding in other fields. That's all. Thanks.